Last meeting, I started to solve this problem. I would like to repeat it one more time. After you are done with reactions, we have vertical reaction downward, YA, XA equal 12, YB equal 54.75. I will draw vertical lines at every single part of the beam and draw three copies. One for normal force diagram, shear force diagram, bending moment diagram. The common question, I'm gonna start from left. Do you have any force at this end parallel to this beam? Yes, we have. We have XA. How much? 12. This 12 pulling or pushing the beam, pulling. So it's a tension. Tension means positive. 12. This 12 will be constant to another 12 here, which is a horizontal force. We have tension. For shear force diagram, I'm gonna start from left. Go up if the force goes up. Go down if the force goes down. If you start from this left, let me draw this shear here. We have at this left, YA goes down, how much? 2.75. So I will go down 2.75. Because we are inside distributed load, can you see? This part of the distributed load, and we have reaction here 2.75. What should I do? That's normal. Keep walking, but dotted. Why dotted? Because you are inside distributed load. Until you found the equivalent load 16, so I will go down one more time 16 until reaching 18.75. Keep walking, dotted. I am done with the distributed load. I am done with the distributed load. This distributed load looks like this. We have here reaction 2.75, and we have equivalent load here 16. What I did, I went down 2.75, keep walking constant until 16, so I will go down 16 until 18.75, then keep walking. Because you are inside distributed load, I walked normally, but dotted, like this. That makes sense? By the end, I have another force here going down 20. So I will go down one more time, 20, until reaching 38.75. Keep walking. Solid. Why solid? Because we don't have distributed load here. We have reaction here, 54.75. So if you go up, I will go up until 16. Keep walking to the end of the beam. You have another 16 here going down. So if you go down 16, I'm gonna reach to 0. Positive, negative. Guys, please go back to the part you draw dotted. From the beginning to the end, please go ahead and draw a solid line. From the beginning to the end, draw a solid line. Once you did, you are done with the shear force diagram. I covered this last meeting. I would like to continue to draw the bending moment diagram. For bending moment diagram, I will start from left. We have M1. Then I will stop at this end, and then stop here, and then stop at the end. So I'm looking for M2, I'm looking for M3, I'm looking for M4. For bending moment, we don't need to stop at the equivalent load of the distributed load. We need only at the beginning, we need only at the end of the distributed load if you are drawing bending moment. Anybody, can you remind me what is the bending moment value at the beginning? What is the moment? What is the value of M1? Do you remember last meeting? We have three cases or four cases: free end, hinge support, roller support, or fixed support. If you have free end without moment, M here equals 0. Hinge, M here equals 0. Roller, M here equals 0. If you have fixed, we have moment, equal value, because we have reaction at the moment. So what is the case here? I believe we have hinge at the beginning, so M1 will be 0. What is the value of M2? Do you remember that? M2 equal previous moment, which is M1, 0, plus area of shear between point 2 and point 1. Do you have area of shear? Yes, we have this trapezoid. What is the area of this trapezoid? It's negative. Yes, what is the area? 2.75 plus 18.75 divide 2 times the distance in between 4. What I did, guys, I added this base plus this one divide 2 times the distance in between the two bases, which is 4 meters. Anyway, the value here will be negative 43. Negative means we are down 43. One more time, 2.75 plus 18.75 divide 2 times 4. Yes. What is the value at M3? Value at M3 will be previous value, which is M2, negative 43. Plus, do you have any shear between the 2 points? Yes, we have. How much the area? It's negative. How much? 38.75 times 4. This distance is 4. And this height is 38.75. So the value of the moment, negative 198. So we have a value here, negative 198. M4, what is the value of the moment at the end? M4 equal previous value, which is M3, negative 198, plus area of shear between the 2 points. Do you have area of shear? Yes, we have. Positive 16 times 3. 150, negative 150. So we have a value here, negative 150. Okay, we have 4 values: 150, 198, 43, and 0. Go ahead and connect between these values, but be careful. Between the two values at the beginning of the distributed load and at the end of the distributed load, we are going to draw a curve. This one is a curve, this one is a line, and this one is line. So if you have uniform distributed load and you have two values, one at the beginning, one at the end, we need to connect between both of them by a curve for bending moment diagram. Let's do one more example. Let's do one more example. We have a beam. We are looking to draw axial force, shear force, bending moment diagram. We have two reactions here, YA and XA. We have one reaction here, YB. We have uniform distributed load. Anybody can tell me how much this equivalent load? I need to get an answer. Please go ahead and tell me what is the value of this equivalent load? How much? Any answer? Thank you. Thank you. Yes, it's 1,000. The equivalent load here, how much? 20 times 50 equal 1,000. Thank you. First step for this type of problem, we need to figure out reactions. We have three equilibrium equations, summation f of x equals 0, xa equals 0. Summation f of y equals 0. We have ya plus yb minus 1,000. That's it, equals 0. So ya plus yb equal 1,000. The third equilibrium equation, I'm going to take moment at any point equals 0. I highly recommend to take moment at A. I'm going to assume this direction is positive. So taking a moment at A, XA does not have or have distance. YA does not have distance. 1,000 times 10. YB negative times 20. Plus 200. What is the distance for the 200? I'm still repeating. What is the distance between this location for 200 and the point A? What is the total distance? Any answer? What is the total distance between 200 and point A?
There's no distance because it's already a moment.
We don't need distance. There is a distance already, 30, but we don't need distance because 200 is a moment, does not need distance. 200 is a moment, does not need distance. I'm still repeating every time, and I believe some of you will do this mistake in the exam, I believe. 200 does not need distance because it's a moment. 200 does not need distance because it's a moment. 200 does not need distance because it's a moment. Equals 0. This term will be cancelled. This term will be cancelled. The only unknown is YB. YB will be plus 200 divided 20, 510. If you put YB equal 510 here, YA will be 490. Yes, 490. So YA equal 490, YB equal 510, XA equal 0. Guys, keep it in your mind during the exam. Please try to do calculations for reaction on this left side. And keep or leave this space free. Why? Because I'm gonna draw. I will draw vertical lines, and draw 3 copies. One for normal force diagram, shear force diagram, and the bending moment diagram. Be organized. Be organized in the solution. For your homework, for your exam, you have the page. Please, on your left, do your reaction calculations. On the right, do your drawing underneath the given beam. Okay? So, for normal force diagram, I'm gonna start from left. Do you have any horizontal force parallel to this beam? Yes, we have. XA, how much? 0. We don't have normal force diagram. Piece of cake. I will start from left. Do you have any force going up or going down? Yes, we have. YA going up by 490. Keep walking, but you are walking inside distributed load. So I will walk normally, but dotted, until you hit the 1000. I will go down 1000 until 510. Keep walking normally, but dotted. We are done with the dotted line. We have reaction YB 510. So I will go up 510 to reach to 0. You are lucky. Then keep walking at 0. Keep walking at 0. Do you have anything to go up or down? No, we are done. From the beginning of the dotted line to the end of the dotted line, I'm gonna draw a solid line. This one negative, this one is positive. We need to start for moment at this one, M1, at the end of the distributed load, M2, and M3. What is the value of M1? 0. M1 equals 0. Do you agree? M1 equal 0. We don't, this one is hinge, so it's 0. M2. What is the value of M2? Equal M1, which is 0, plus area of shear in between. Do you have area of shear between the 2 points? Yes, we have. Unfortunately, we have this little triangle and this little triangle between point 2 and point 1. Okay, what is the problem? The problem is, anybody knows where is this point? What is this distance? And what is this distance? Why you need to calculate these distances? Because I need to calculate the area. The area of a triangle is 1/2 time base time height. What is the value of the base distance? The total distance is 20. Let me explain it here. We have a value here, 490. We have another value here, 510. We know the total distance is 20 feet, I believe. 20 feet, yes. What is the distance here? And what is the distance here? Don't tell me this distance is 10 and this one is 10. That's wrong. That's wrong. Because this height is not equal to this one. This one is 490, this one is 510. So this intersection not at the midpoint. So what can I do? Okay, you can assume this one is x. That means this one will be 20 minus x. I can say this triangle is similar to this triangle. So 490, which is this height, divide the similar one, 510, equal this distance x, divide this similar distance, 20 minus x. We have one variable unknown, which is x. I can figure it out. The value of x will be 510 9.8 feet. So this distance equal 9.8. That means this distance equal 10.2. So this distance is 9.8. This distance is 10.2. If you would like to get the value of moment here, this moment equal previous value 0 plus area of shear between the 2 points. We have this triangle, which is positive 1/2 times 9.8 times 490. This moment will be 2,401. So the value here is 2,401 positive. Value of M2, previous value, which is for 2,401, plus area of shear between the 2 points, this negative triangle, negative 1/2 times 10.2 times 510. This value will be negative 200. So we have a value here negative 200. What is the value of M3? Previous value, which is negative 200. What is the area of shear between point 3 and the point 2? Do you have any area of shear? No, we don't have. So the value will be negative 200. So we have another value here, negative 200. Between this value, I'm gonna draw lines. This is a line, but this one is a curve from this point to this value to this value. Why you are drawing a curve? Because you are drawing inside distributed load. Okay? Because you are drawing inside distributed load, so bending moment diagram must be a curve. Outside the distributed load, you are drawing a line. So guys, one more time. if you have this shape of the shear force diagram, I highly recommend to calculate moment at the beginning, calculate moment at this location, and calculate moment at the end. Like I did here, moment at this point, moment at this point, and the moment at this point. By the way, the value of the moment at this location will be the highest value of this parabola. The highest value of this parabola will be at this location because this location is a point of zero shear. I'm sorry, what you mean by zero shear? Okay, we have a value here of shear 490. This value is going down, going down, going down, going down. How much here? How much shear here? Do you have shear at this location? No, we have zero shear. If you have zero shear, you can expect maximum moment. Or you can expect the highest value of the parabola. And I covered this before, if you remember. We have a rule here. Maximum bending moment occur at the value of shear is zero. Do you remember that when I told you if you have a parabola, at this location we have a tangent and this tangent has a slope. But the highest value of this parabola, the tangent will be horizontal. That means the slope equals zero. That means shear equals zero. This is what I did here. If you have zero shear, we can expect the highest value of the parabola. Anyway. Do this one as a homework. You don't need to submit it. You don't need to submit it, but just do it for practice. Probably, I'm not sure, you can find this one in the exam. I'm not sure. Let's do this problem. Let's do this one. We have a beam and we need to draw the axial force. Guys, what is your suggestion? To calculate reactions first. I gave you some rules to calculate reactions if you have pin connection. Do you remember that? If you have a pin connection, I will do separation. This is the first part. And here is the second part. Does that make sense? We have here a force, 4 kb, and we have support A. We have 2 reaction. I'm sorry, it's roller. This one is roller. So we have 1 reaction, YA. We have concentrated load here. How much? 8 kb. At this connection, it's a pin connection. So we have 2 reactions, 1 vertical and 1 horizontal. I'm gonna assume it YD and XD. Anybody can tell me how can I figure out the reaction on the other side? Do you remember? We will have the same 2 reactions, but in opposite direction. So YD will be down. XD will be to right. At point B, we have vertical reaction only, YB, and we have a given moment, how much? 15. What else? We have inclined force here, 12. And we have at C hinge. So we have vertical reaction YC and that's fine. We have horizontal reaction XC. Do you have any comment? Do you have any problem? Do you have any issue? So for this problem, we have two parts. The first part, how we can figure out the reactions. So please keep in your mind, if you have pin connection, we need to do separation to be able to figure out the reactions. If you didn't separate, you have something wrong. We have two problems for the first one, but before starting to apply equilibrium equation, this inclined force will be broken to horizontal and vertical components. I will do it quickly. So 4 times cosine 30, the vertical one will be 3.5. And the horizontal one will be 2. What else? This inclined force, we will have two components, one horizontal and one vertical. The horizontal one will be 7.2 and the vertical one will be 9.6. We are good. Apply summation f of x equals 0. So we have we have negative 2. We have negative xd equals 0. So xd will be negative 2. Summation f of y equals 0. We have negative 3.5. We have positive ya. We have negative 8. We have positive yd equals 0. Take moment at d equals 0. I'm going to assume this direction is positive. If you take moment at d, this one will be cancelled. This one will be cancelled. I believe the only unknown will be ya. The value of ya will be 8 times 2 plus 3.5 times 12 divide 6. This one will be 9.67. If you put here ya 9.67, you can get yd. It will be minus 3.5 minus 8. It will be 1.83. So yd equal 1.83. ya equal 9.67. xd will be in the opposite direction. Why opposite direction? Because your value is negative. How much? 2. If you switch the direction, that means it will be in this direction on the other side. Must be opposite. How much? 2. yd, how much? 1.83. Then I will go to the other part. Apply summation f of x equals 0. We have negative 2. We have negative 7.2. We have negative xc equals 0. The only unknown is xc will be negative 9.2. So this reaction is 9.2, but in opposite direction. Summation f of y equals 0. What do you have in y? We have negative 1.83. We have positive yb. We have negative 9.6. We have positive yc. So yb plus yc equal 11.43. I'm gonna take moment at C equals 0, assume this direction is positive. Taking a moment at C will cancel this one and this one. The only unknown you have will be YB, I believe. The value of YB will be 9.6 times 8 minus 15 plus 1.83 times 888 24 divide 16 6.6. If you put YB equals 6.6, you can get YC 4.9. So, the final conclusion, at this roller, we have vertical reaction YA equal 9.67. At this roller, we have vertical reaction YB, how much? 6.6. At this hinge, as a final conclusion, we have YC equal 4.8, and the horizontal reaction here to right, how much? 9.2. Please, this separation only to calculate reactions. This separation only to calculate reactions. Once you did your reaction, please go ahead and put the correct direction of your reactions. And forget what you did at D. Forget it. That makes sense? So keep in your mind, we have horizontal component here and vertical component 3.5 and 2. We have horizontal component here and the vertical component, how much? 9.6 and 7.2. Any questions so far? Guys, any questions so far? Because this problem is very important. First step, which is how to calculate reactions. We learned it before, if you have pin connection, we need to do separation to be able to calculate reactions. This is what I did. And we have two parts, part number 1 and part number 2. For part number 1, I applied equilibrium equation. For part number 2, I repeated the same equilibrium equations. Finally, I found YA, YB, YC, and XC. So if you decide to start to draw, please go back to the original problem and forget what you did at D. We have XD and YD on this one and this one. Actually, both of them will cancel each other if you go back to the original problem. So I will start to draw vertical line, vertical line, vertical line, vertical line, vertical line, vertical line, and vertical line. Then I will draw 3 parts. One for normal force diagram, for shear force diagram, for bending moment diagram. Let's start with the normal. Let's start with the normal, which I'm gonna start from the left. Do you have any force pulling or pushing this beam? Yes, we have. How much? 2. So we have positive 2. Please walk constant. Walk constant. Nothing happened. Nothing new. Nothing new. Hop until this point. We have another force here parallel to the beam. Starting from this point until you reach to this point. Do you have any horizontal force parallel? No. So this 2, which is positive, remain constant. until you found 7.2. My question is, do you think 7.2 will help 2 or will decrease 2? Any answer? 7.2 will increase or will decrease the value 2? What do you think? Guys, 7.2 at this location to left will help or will reduce the value 2? Help? Decrease? That makes sense because the answer is very, very simple. 7.2 in the same direction like 2 or opposite direction? 7.2 in the same direction like 2. So this value will increase to 9.2. If you keep walking to the end, you can find the 9.2 in opposite direction. You will go to down 0. So guys, the idea is here. We have a beam. At this location, we have 2. At this location, we have 7.2. At this location, we have 9.2. That makes sense? Yes. And we need to draw axial force. So I decided to start from left. You have a force here? Yes. Barrel? Yes. How much? 2. My question is very simple. This 2, pulling or pushing? This 2 is pulling, so it's a tension, so it's positive. Please walk constant. Previously, we don't have anything else, so I will draw constant to the end of the beam. But this is not the case this time, because we have another one inside the beam. So please be careful. So I will go constant until reaching 7.2. Don't be confused. Just ask yourself one question. Do you think this direction in the same direction like 2 or not? If the same direction, this value will increase to 9.2. If this one in opposite direction, this value will decrease. That makes sense? Okay. Keep walking. Here is the question. We have another force here. The question is very simple. This direction, in the same direction like this one and this one? No. So we will decrease from 9.2. I will decrease it by 9.2, so I will reach it to 0. Here is the normal force diagram. To draw shear, I will start from left, so I will go down 3.5. Keep walking until 9.67. 9.67 minus 3.5, so I will go up to 6.17. Then keep walking until you found 8. I will go down 1.83. Keep walking, nothing until 6.6. So I will go up by 4.77. Walking until you have 9.6. So you will go down to 4.9. Keep walking until you found 4.9 going up. So I will reach to 0. I'm sorry, this one is 4.8, not 9. 4.8. negative, positive, negative, positive, negative. We need to figure out the value of moment here, the value of moment, the value of moment, the value, the value, the value, the value. M1, M2, M3, M4, M5, M6, M7. M1 is 0. We don't have a value here. What is the value of M2? Previous value plus this area of shear. I can do it with my calculator. So it will be 3.5 times 6. It will be negative 21. The negative 1 M3 equal previous value, which is negative 21, plus area of shear in between this little area of shear, 6.17, time this little area distance 4. It's positive 3.68. The next one, M4, previous value, plus area of shear between the 2 points, this little area, negative 1.83 times 2. Your value will be 0. M5, previous value, which is 0, plus area of shear in between, which is negative 1.83 times 8. This one will be negative 14.6. This one, how much? Previous value plus area of shear in between, 4.77 time this distance 8 will be positive 23.5. 23. The last one will be 0. I have a mistake here. I have a little mistake here. This value is good. I will connect between 21 and 3.68 and 0 and 14.6. All of these values are correct. For this value, we have a concentrated moment. If you go back to our rules, if you have concentrated moment, you will expect vertical jump in the bending moment. This vertical jump to up or to down, if the moment is clockwise, it will be positive to up. If this counterclockwise, your jump will be to down. Let me ask a question. This moment direction is counterclockwise or clockwise? It's counterclockwise. So your jump will be to down. You are at 14.6. I need to go down another 15. So your value will be 29.6. So if you are calculating moment M6, the previous value will be negative 29.6. Plus area of shear in between, 4.77 times 8, you will have positive 8.5. The last one will be negative 4.8 times 8. You will have 0. So you can connect between these values. Just a second. I believe I have a mistake here also. Hmm. $29.6 plus 4.77 times 8. Just a second. 29.6 plus 4.77 times 8. 8.5 minus 4.8 times 8. Okay, anyway. So please keep in your mind, if you have concentrated moment, you should expect drop. You have a value here, so you should expect drop in the bending moment diagram to down or to up. Based on the direction, you will go up if this one is clockwise direction. You will go down if this one is counterclockwise direction. Okay. We need to figure out how to draw axial force diagram, axial, shear, and moment in the case of frames. It's very simple, nothing new except one step. Let's see. We have a frame, this frame, and we are looking to draw axial, shear, and the bending moment diagram. First step, you need to figure out the reactions. This frame is roller at A, so we have one reaction at A, YA, is hinge at C, so we have two reaction YC and XC. Okay, let's start to do the reactions. My question is, do you have any pin connection? No. Do you need to do separation before starting to do reactions? No, we don't need. One more time. Do you have pin connection? No. Do you need to do separation before starting to calculate reactions? No. So I didn't do any separation. This equivalent load, how much? How much? 1.5 times 10 is 15 kip. We have three equilibrium equation. Summation f of x equals 0. We have negative 2. We have positive x c equals 0. So xc equal 2. Summation f of y equals 0. We have ya negative 15, positive yc equals 0. So ya plus yc equal 15. The third equilibrium equation, summation moment. I'm going to take moment at C equals 0. I'm going to assume this direction is positive. Taking a moment at C, xc times 0, yc times 0, 2 times 6. Guys, this 2 times this 6. Plus 15, this 15 times what? Horizontal distance between this load and the point C is 5. Minus YA times 10 equals 0. This term will be cancelled. This one will be cancelled. The only unknown is YA. 8.7. If you put YA 8.7, we can get YC equal 6.3. So finally, YC equals 6.3, XC equal 2, YA equal 8.7. Any questions so far? Any question so far? One more time. You have a frame. I need to figure out the reactions. My question is, do you have pin connection? If you have, we need to do separation to calculate reaction. If you don't have, we don't need to do separation. Any questions so far? Before starting to draw, we need to do a new step for frames only. I'm gonna make cut. I will do cut for each member alone. Previously, you have this reaction 2, this reaction 6.3, and this applied load 2. Previously, you have this reaction 8.7 and this uniform distributed load with equivalent value, how much? 15. At this cut, I'm sorry, you said cut? Yeah, I said cut. It's not separation because it's not pin connection. At this cut, we can expect 3 reactions, 1 vertical, 1 horizontal, and 1 moment. So this point called B, I will have XB, YB, MB. These 3 reactions will be the same, but in opposite direction. YB will be down, XB will be to right, MB will be counterclockwise. Let me explain it to you. Guys, sometimes we have something called pin connection. Sometimes we have rigid or fixed connection. This one looks like this. This one looks like this. Pin connection means we have 2 members. This member alone, this member alone. We did hole, and we connected the 2 members by a bolt. So it can be called pin connection. In this case, we have here only 2 reactions, and these 2 reactions will be the same value, but in opposite direction. If you have rigid or fixed connection, that means this member and this member are 1 unit. We cannot do separation, but we can do cut. So I will do cut here. This member alone and this member alone, but we did cut. So we have 3 reactions, 1 vertical, 1 horizontal, 1 moment. 1 vertical, 1 horizontal, and 1 moment. Does that make sense? This is the difference between this case and this case. I need to do separation in this case to be able to calculate reactions. In this case, I need to do cut to be able to draw the internal forces. This is what I'm doing right now. I did cut. It's very simple. Just go ahead and use this part. Summation f of x equals 0. Do you have any horizontal force except xb? No. xb equals 0. And this xb will be 0 also. Summation f of y equals 0. We have positive 8.7 we have negative 15, we have positive YB equals 0. So YB, how much? 6.3. So this reaction is 6.3. That means this reaction will be 6.3 also, but in opposite direction. If you take moment at B for this part, summation MB equals 0, MB will be the value of MB 15 times 5 minus 8.7 times 10, it will be 12. Just a second. I will assume this direction is positive. So this one is negative. Yeah, it will be negative 12. So this one is negative 12. And this value will be negative also, 12. So the final conclusion for this frame, we have this part with reaction here and the equivalent load here 15 and the reaction here 6.3, 8.7. This reaction is 0. Does that make sense? Yes. So what is the normal force diagram for this part? What is the shear force diagram for this part? What is the bending moment diagram for this part? Looks like a beam. This one or this part looks like a beam. We don't have any force parallel. 0. I'm gonna start from left. I will go up 8.7, dotted, go down to 6.3, move close to 0. From the beginning of the dotted line to the end, I'm gonna draw a solid line. Why you are walking dotted? Because it's distributed load. For bending moment, your value here is 0. I can figure out the value here. And what is the value at the end? We can draw the bending moment diagram. Your moment will be, looks like this. Exactly. 12. And you have a value here. The next part, we have a part here. We have 2, vertical reaction 6.3, horizontal reaction here 2, and vertical reaction here 6.3. This horizontal one is 0, and your bending moment diagram is 12. I'm gonna assume this part looks like a beam. We need to draw normal force diagram, shear force diagram, and the bending moment diagram. But please rotate your problem. So I'm gonna sit down here like this because I'm assuming this one looks like a beam. Do you have any force parallel from your left? Here is the left. Do you have any force parallel? Yes, we have 6.3 pushing. So we have negative 6.3. From your left, we have a vertical reaction. How much? 0. So I will go up 0. Move on the 0. Until 2, I will go down 2. Move until you found another 2 go up. So here is the shear force diagram. For bending moment diagram, we have a value here 12, negative. Because the value of this moment is negative. I can figure out the value here will be also negative 12. And the value here will be 0. So you can draw your bending moment diagram looks like this.